Hi, in previous lecture I discussed LCS, longest common subsequence. If x and y are two sequences, then we want to find maximum length common subsequence from both. I also discussed optimal substructure of LCS. If two sequences are given, x equals to x1, x2 up to xm, y equals to y1, y2 up to yn, and if there is a matching, means if xm equals to yn, the next time we'll find LCS from xm minus 1 and yn minus 1. So if there is a matching, we'll reduce the size and we'll try to find LCS from the remaining. I also discussed one example where every time we are reducing the size if it is a match and we are finding LCS from the rest. I also discussed the recurrence relation for LCS length. Suppose Cij is the LCS length, then it will be 0 if either I or j equals to 0. Then it will be Ci minus 1, j minus 1 plus 1 if it's a match, means x of I equals to y of j. If it doesn't match, means x of I not equals to y of j, then it will be maximum of Cij minus 1, Ci minus 1 j. I discussed one algorithm for LCS length. Its running time is theta of mn. M is x length, n is y length. Next I will discuss one example. Suppose x equals to abc bd ab, y equals to bd ca ba. Now we will create a table for finding LCS length. So this is the table. I is at left side, j is at top. So this whole table is C. C index are 0 to m, 0 to n. Whereas this table, this inner table is B. B index are 1 to m, 1 to n. C table will contain the Cij value, while B table will contain the RO, from which value we are deriving this value. Then for I equals to 1 to m, Ci0 equals to 0. So this first column will be 0. For all I value, when j equals to 0, it will be 0. Or from the recurrence relation, if I equals to 0 or j equals to 0, here j equals to 0, so this value will be 0. Next, for j equals to 0 to n, C0j equals to 0. So this first row is 0. So whenever I or j equals to 0, Cij will be 0. Next we'll compare A with B. Is A equals to B? No. So when it doesn't match, we'll take maximum value from these two. Both are equal. Now just check this. Else if Ci minus 1 j greater than equals to Cij minus 1. This 0 equals to this. So we'll write 0 and arrow direction will be upward. From the upward 0, we derive this 0. We need to compare these two value. Whichever is greater, that will write here. Or if it is equal, then we'll write the top value and arrow direction will be upward. Next, is A equals to D? No. Now compare these two. Is this 0 greater than or equals to this 0? Yes, it's equals to, we'll write 0, arrow direction will be upward. Next, we'll compare A with C, doesn't match. Now compare this to 0. So here we'll write 0, arrow direction will be upward. Next, A with A, it's a match. When xi equals to yj, Cij will be Ci minus 1, j minus 1 plus 1. So this 0 plus 1. We'll write 1 and arrow direction will be toward left corner. From this 0, we derive this value. From which we are deriving the value, arrow direction will be toward that. So when it's a match, Ci minus 1, j minus 1 plus 1. And arrow will be toward Ci minus 1, j minus 1. Next, compare A with B, doesn't match. So maximum from these two, maximum is 1. We'll write 1 and arrow will be toward left. Next, is this A equals to A? Yes. So we'll write 0 plus 1. It will be 1 and arrow direction will be toward left corner. As this one, we derive from it. Now next row, B equals to B. Yes. We'll write 1, arrow will be toward left corner. Next, B equals to D. No. So compare these two. 1 is maximum. 1, arrow will be toward left. Next, B equals to C. No. Compare these two. 1 is maximum. We'll write 1. Arrow will be toward left. Next is B equals to A. No. Compare these two. This one is equals to this one. So when greater than or equals to, arrow will be toward up. So I'll write 1 and arrow direction will be toward up. Next, compare this to B. It's a match. So I'll write 1 plus 1. I'll write 2 and arrow will be toward left corner. Next, B with A doesn't match. Now compare this two. This is maximum. So let 2, arrow will be toward left. Next row, compare C with B. Doesn't match. Now from these two, 1 is maximum. So let 1, arrow will be toward up. Next, C with D. No match. So from these two, we'll write 1. Both are equal and arrow will be toward up. Next, C with C. It's a match. C equals to C. We'll write 1 plus 1. So it will be 2 and arrow will be toward left corner. Next, C with A. Now maximum from these two, 1 and 2. Maximum is 2. We'll write 2, arrow will be toward left. Next, C equals to B. No. Now this 2 equals to this 2. So we'll write 2, arrow will be toward up. Next, C equals to A. No. So 2 equals to 2, we'll write 2, arrow will be toward up. Next, fourth row, compare this to B. B equals to B, we'll write 0 plus 1. We'll write 1 and arrow will be toward left corner. Next, B with D. Now this 1 equals to 1. We'll write 1, arrow will be toward up. Next, B equals to C. No. Now from these two, maximum is 2. We'll write 2, arrow will be toward up. B equals to A. No. From these two toward equal, we'll write 2, arrow will be toward up. Next, compare these to B. B equals to B. So we'll write 2 plus 1. It will be 3, arrow will be toward left corner. When it's a match, we'll add plus 1 with the previous corner value. It's not equal to, now from these two, maximum is 3. We'll write 3 and arrow will be toward left. Next, fifth row is D equals to B. No. We'll write 1 and arrow will be toward up. D equals to D. Yes. So this 1 plus 1, we'll write 2 and arrow will be toward left corner. Next, D equals to C. No. So we'll write 2, arrow will be toward up. D equals to A. No. We'll write 2, arrow will be toward up. D equals to B. No. Now from this 3 and 2, 3 is maximum. We'll write 3, arrow will be toward up. Next, D equals to A. No. We'll write 3, arrow will be toward up. Next, sixth row is A equals to B. No. We'll write 1, arrow will be up. Next, A equals to D. No. We'll write 2. From these two, 2 is maximum. We'll write 2, arrow will be toward up. Next is A equals to C. No. Next, we'll compare these two. It's equal. We'll write 2 and arrow will be toward up. So whenever it's greater or equal, arrow will be toward up. Next, compare A with A. It's a match. So we'll write 2 plus 1. We'll write 3 and arrow will be toward left corner. Next, A with B. It's not equal to. Now compare these two. 3 equals to 3. We'll write 3. Arrow will be toward up. Next, A equals to A. So this 3 plus 1. It will be 4 and arrow will be toward left corner. Now last row, B with B, it's a match. We'll write 0 plus 1. We'll write 1, arrow will be toward left. Next, B with D, it's not equal to. Now maximum from these two, it's 2. We'll write 2, arrow will be toward up. Next is B equals to C. No. This 2 equals to 2. So let 2, arrow will be toward up. Next, B equals to A. No. Now from these two, 3 is maximum. So let 3, arrow will be toward up. Now B equals to B. Yes. So when it's a match, we'll write 3 plus 1. 3 plus 1 is 4 and arrow will be toward left corner. Next, B equals to A. No. Now is this 4 greater than or equal to this 4? Yes. So let 4, arrow will be toward up. So for this example, LCS length will be 4. By this table, we just got LCS length. So this algorithm is just for finding LCS length. Next, I will discuss how we can find the LCS. We simply begin at BMN and trace through the arrow in the table. So toward the arrow direction, we'll trace. Whenever we encounter a left corner arrow, that means xi equals to yj. So with this method, we encounter the elements of LCS in reverse order. So the following recursive procedure print the LCS of x and y in proper forward order. We'll trace in reverse order, but it will print in forward order. This procedure take order of m plus n. M is x size, n is y size. So since it decrement at least one of I and j at each recursive call, so running time is order of m plus n. Print LCS b x I j. As in LCS, whatever the x value, that will be in y value also. So that's why we don't need to write y. So just x, I and j. If I equals to 0 or j equals to 0, return. If string length is 0, then no LCS. If bij is left corner arrow, then print LCS bx I minus 1 j minus 1. Again we will call recursively I minus 1 and j minus 1. Then we will print xi. Else if bij equals to upward arrow, then we will call bx I minus 1 j. Else if it is left arrow, then we will call print LCS bxi j minus 1. So this is the procedure for finding LCS. Let me run this procedure in previous example. We already found the table. Now on that table, I'll run this procedure. So we'll trace from last ij. Here last I is 7 and j is 6. So we'll start tracing from the last corner. Here I equals to 7, j equals to 6. So it's not equal to 0. It's a upward arrow. So we'll go to above step. So from B7, 6, now we're going to B6, 6. Then here there is a left arrow. So we'll go to left corner, in 3 toward up, here in 3 toward left corner, here in 2 toward left, here in 2 toward left corner, then in 1 toward left, then in 1 toward left corner. Now just mark this corner arrow. So here is a 4, it's for A and A. So A is a match. Next for these 3, it's B. This B is present in both. That's why here just written print xi. Next for these 2, it's for C. Next for this 1, it's for B. So we got B, C, B, A. We just got one LCS. By this algorithm, we can find only one LCS. But in exam, it may ask multiple LCS. There may be present multiple LCS. So how will find multiple LCS from this table? Just ignore upward arrow and left arrow. Just focus on the left corner arrow. Now here is a left corner arrow. It's for B. Next another left corner arrow. That's for D. Next here is a left corner arrow. So we got A. Here is a left corner arrow. So we got B. We got B, D, A, B. Now this B, then C, then A, then B. So B, C, A, B. That can also be LCS. So we got 3 LCS, B, C, B, A by this procedure. Then B, C, A, B and B, D, A, B by just following the left corner arrow. In today's lecture, I discussed one example of finding LCS length. We got 4 for this example, and how to construct LCS by using the procedure PRINT-LCS. So by that we can get one LCS. I also discussed how we can find multiple LCS from this LCS table. In next lecture, I will discuss one more example for finding LCS length and multiple LCS. If this lecture is helpful for you, please like, share and subscribe. Thank you.